surprising sometimes. So problem number one, I'm guessing quite a few of you got that one correct. Um, and the issue here, all I'm testing in problem number one is, do my students know what to do when you have this, by the way, this thing I'm circling is called a power. The four is not the power. The whole egg is called a power. Okay. It consists of two parts. It consists of what we call a base and an exponent. We sometimes casually say like x to the fourth power. I get that. But a power is both parts of it put together. So if you have a power times another power, and the powers have the same base, you need to know from this moment on that you keep the base the same and you add the exponents together. That is it. That's all problem one was intended to do, was to make sure that we all are down with that. I understand completely why you would want to say x to the 20th, but going all the way back to the first time we learned this, I can make a very strong case to rebut your theory. X to the fourth looks like that, and x to the fifth looks like that. And you just can't deny me that there are 9x's in front of me. It's like irrefutable evidence that the answer has to be x to the ninth power. So take away from that that when it is a power times a separate power, that I will keep the base and add the exponents. Question number two is testing, do my students know what to do when I have a power and I raise that power up to another exponent like this? And the answer obviously is we're not going to add. Like, we wouldn't do something like do the same thing with this situation as we would with the last. And so this one, I want everyone to know that when you have a pre-existing exponent and you exponentiate once again, it's like a double up exponents, that you will multiply those exponents together. So you will keep the base the same, but 3 times 6 makes 18. So questions 1, 2, 3, and 4 are all very deliberately written with just the basic properties in mind. Nothing fancy. So in problem 3, I want to know if my students know what to do in this situation. If you have a power, again, let's be clear, I need to start using my vocabulary more. That's a power. And this is a power. The 10 and the 2 are not the powers. They're the exponents, okay? If you have a power and you divide it by another power, provided that the bases are the same, which they are, they're both W's, then my answer is that I keep the base the same and I subtract the exponents. 10 minus 2 is 8. The 4 properties that I'm trying to test you on are the addition one, the multiplication one, the subtraction one, and then the last one is the distribution one. So the fourth question is the last of the really super introductory basic ones. And what I'm saying here is that if I have multiple things, like a to the second is a thing, right? And I have another thing multiplied right next to it, b to the third, and I raise that to some exponent, like 4, -2, 5, 9, it doesn't matter. That what I have to do is I have to take that exponent that's on the outside and I have to distribute it to each of the items on the inside. This involves two powers, or excuse me, two properties. And so the first thing that happens, I should recolor these. I'm going to do like a red arrow and a green arrow. So when I do the red arrow, I look at it like this. I already have a to the second, and I'm taking it up to the power of 4. So that, you would agree, is going to involve the property that I just circled up there, right? And then the second one, the green arrow, I already have b to the third. and I raise it to a new power of 4. And I can see again that I'm now using the distribution property first, but then this big red oval property second. What will I do with my exponents in these red and green situations? And yeah, and if every one of you doesn't know that, I just would like to know that because I feel like that's where we're at today is I just need to know. You know not to add those. You know to multiply those. So the red one is going to become a to the power of 2 times 4, and the green one's going to become b to the power of 3 times 4, like that. So, having said that, are we all solid good on the 4 basic properties? When to add, when to multiply, when to subtract, and when to distribute. All right. So let's get into now combining some stuff. And so when we get to problem 5, we have a combination sort of things that's happening. So we have a lot of things here. We have a 3 with an x to the third and an m to the fourth. And honestly, I things like this in math used to drive me nuts as a kid. I might ask the question, why didn't you put that in parentheses? And my answer is because I just don't sometimes. With multiplication, you just don't really, if everything's just multiplied together, parentheses or no parentheses, we just know what's going on. So the question might be, well, then why did you put this one in parentheses? And the answer is, I don't know. I just kind of felt like it. I knew that this was what some of the delta math problems would look like. So I was just trying to mimic that when I typed this one up. One of the most common mistakes that I see is that students view this as I know this is going to have something to do with that property where I add stuff together. And one of the most common mistakes that I see is students say 3 and 5. I'm going to add those and make 8. You've got to work that out of your system. What kind of math problem is that? What did I just circle? What is that? It's a multiplication problem all day long. And you can't abandon what you've known since like quite literally fourth grade. You've known since fourth grade that 3 times 5 makes 15. So don't think that those numbers have anything to do with what we're learning in class right now. That's just what it's always been since the olden days. Would you just open it and get it done? Like I can't have think just that's what it should be every time. 3 seconds and we're done. Now we're going to move on and we're going to do the first variable. I like to go alphabetical. No one's ever going to tell you that you're wrong if you don't, but it's what a proper mathematician generally would do. So I'm going to say first in the alphabet is M. And I see that there's a power here and a power here. What am I going to do with those exponents? I'm going to multiply the powers, but what am I going to do with the exponents? I'm going to add them. That's the first property we addressed today, is that when I have a power and an entirely separate power, I add the exponents together. So the m stays the same, but his new exponent is 4 plus 6, 10. And then I'm going to identify that this is a power and this is a power. Most of you got the memo on this, but there's still like probably 5 or 6 of you that didn't. Does the second power, the one with the yellow arrow, does it have an exponent? It does. You just can't see it. So if it helps you, I know a lot of you guys have gotten through a lot of stuff we've done. You're pretty comfortable with adding ones onto things. Put a 1 there if you want, because x to the power of 1 may help you to see what we have to do. So if I take the yellow eggs and I multiply them together, what do I do with their exponents? I add them, and 3 plus 1 is 4. Got it? Question 6 is essentially a rehash of question 5. So there is no distribution. It's just another problem. Honestly, I think when I wrote this, I was just thinking I'm going to do one now where both parts of it are in parentheses just to make sure you guys you understand it doesn't matter. So I've got a bunch of stuff in here times a bunch of stuff in here. And this really is exactly the same as the last problem. I'm just going to go, you're not allowed to call this combining like terms, but in your, like if you say it, I'm not going to get upset with you. It's just not technically what in math we mean when we say that. Combining like terms means like adding and subtracting them. But if that gets you through the day, call it whatever you want. So I'm going to identify that there's regular numbers. There's a -2 times a +4. What does that equal? And again, you've known that for years. This is nothing to do with ninth grade. It's you just know that. Now we get on to the math, the algebra part. And so we identify that this is a power and his similar power is over here. When I put those together, how many C's will I have? There, yeah, there's 10 plus the one you can't see. 10 plus 1 makes 11. And then when I go and do the D's, this power has 11. This power again has 1. So it's a total of 12. Any questions so far? Okay. On to then the third row we go. And so on this one, we start. This is where I anticipated that the difficulties would kind of start. I didn't foresee a major collapse, but there's one thing in this problem that is very hard to learn. What's the first property that we're going to use? Because we got to use a couple. What's the first thing we're going to do? Yeah. And call it the distribution property. Give them names if you want. It's fine. So I'm going to take, I apologize that I didn't copy the problem down completely. I'm going to take the exponent on the outside and I'm going to distribute him. So I'll do this in colors for you. He's going to first go to that number, and then he's going to go to that power, and then he's going to go to that power. As many things as are inside, that determines the number of jobs he has to do. The first one, the purple one, is going to say -4 to the power of 2. Someone, I think in this class, asked the question the other day, why did I put that in parentheses? And the answer is because the 2 is squaring the negative and the 4. They are presumed to be a team in this case. And so the -4 gets squared as a package deal. The second one, the green one, is going to say x to the already ninth being raised up now to another power of 2. And the yellow one is going to say y to the already power of 2 being raised to a new power of 2. This is me showing as much work as I humanly could. Like I couldn't show anything else than this. What is the answer to the purple one? And we don't use calculators. I'm sorry, but it's just not okay anymore to use a calculator. It is +16 all day long. You should not wonder what 4 times 4 is, and you should also understand that a negative times himself would make a positive. So the purple one winds up being 16. What is the answer to the green one? And you may not have been able to answer this 20 minutes ago, but every one of you should now. What is the answer to the purple one? X to the 18. We know now to multiply when it looks like that. And what is the answer to the yellow one? Y to the 4th. Okay. So that concludes the part of this that involves mostly stuff that's just left to right operations. These last 2 questions I want to go over with you involve tops and bottoms. We've seen a little bit of it today, but not the good stuff, okay? So question 8 on your worksheet yesterday had a top like this and a bottom like this. And to be good at this stuff, you have to be faithful and attack it in pieces. It's a patient process, and you have to identify that there are 3 parts to this problem. There's the purple part, the red part, and the yellow part. And I think it's important that you identify those separately so that you know to attack them each in due time. So let's start with the purple part. That is not a high school math problem. It's not even close. It's a fraction. So if I asked you to simplify that fraction, what would you do? Say again? And how'd you get that? Right. Remember, this has nothing to do with Burns High School. This is Burns Elementary School, right? I just divide the top and the bottom both by 2 because I can, and I get a 7 and I get a 4. So what I've tried to show you is that at this point, you can now construct what will be your final answer. And you're going to put the numbers 7 and 4 in their proper places. So you're going to put a 7 up here and a 4 up here. And those guys are just going to wait now for us to or deposit A's and F's wherever they go. About 12, 15 minutes ago, we talked about the red property. What do I do when there's a power and a similar power on bottom? Subtract, right? And so if I take the top exponent and I do minus the bottom exponent, I'm sorry, I say this all the time. Yes, you're not allowed to say that the answer to this is 8. It's like an epidemic. To me, if I have 65 Algebra 1 students and 8 of them say that, that's an epidemic to me. That should be 0 of us should ever think that the answer to that is 8, right? And it should never even like, don't be the person that says, like, when I say what's 2 minus 10, you go 8, -8. Like, don't do that. Like, your first word should be negative. Moment you see big taken away from small, you're like negative all day. And then you can worry about what it is. And then you go, okay, 10 is 8 bigger than 2. So I'm in debt 8. So I'm going to put a to the 8th power on the bottom because it came out as a negative. And then I'm going to do the same thing with the yellows. I'm going to do it in the reverse order. I chose these numbers on purpose. 10 minus 2 is what? 8. And this time it is positive 8. So we're going to take f to the power of 8, but we're going to put it in top like this. Got that? Okay. Let's do it again. Last one, and then I'm going to kind of get out of your way. I'm going to hand out the worksheet. And the worksheet, you're going to have to be a little bit, and I'll help you, by the way. Like, I'm totally down for helping you on the problems that I'm about to hand out. This is not going to be one of those you're on your own situations. Today's going to be like a talking back and forth kind of day. Yes, sir. No, that would be just fine. Um, so our last problem that we're going to talk about today, on top we have -6 W K. And then on bottom we have 9 W to the 4th K. Sorry, part of teaching math is being a broken record. Like, I think there's something to be said for a consistent delivery of steps. So step 1, identify your parts. The purple part has absolutely nothing to do with ninth grade, right? The red part, though, and the yellow part do, right? These are high school problems because we're dealing with variables and exponents. So let's talk purple first. Overall, what can you tell me about the purple? It's negative. You could even stop there and I would be just happy as a clam. If you just said negative, I'm like, thank you. That means so much to me that you would be able to say, okay, here's what I know. My answer is going to be negative. Like, that's huge. And then you can reduce the 6 and the 9. What is something that I can divide 6 and 9 both by? 3, turning the 6 into a 2 and the 9 into a 3. So I can now place those guys. And just like we did in the last problem, they'll just wait for us to pop things in wherever we need to. Let's talk about the red ones. What subtraction problem am I doing with the red? Good. Invisible 1 minus 4, which equals -3. So I'm going to put in a W to the 3, but I'm going to put it on the bottom. And then what am I doing with the K's, the yellows? Yeah, nothing, subtract. There's all sorts of ways we could have this discussion. Some people are just comfortable taking a pen and just saying, cancel them out. Some people want to be more formal about it and say, okay, I'm going to go ahead and do my thing, and I'm going to go 1 - 1, and that's 0. Basically, at the end of the day, what that means is I'm just not putting any of those idiots in. Right? So there will be no K's in my answer. There you go. Uh, so, I mean, there were quite a few of you, probably a half a dozen or so, that really just took that top half and just you did great. Um, but there were a lot of you that I think needed that sort of refresh on what to do. So, JoJo's going to hand out this assignment, and I'm gonna down or what do you call it? Like download or import it into this so that when you guys want to go over questions, we'll go over questions. Right? Operation knowledge acquisition. And as you go through this, you're going to find some of the problems are going to be significantly easier than the others. So this is one that I don't think is significantly easy at all. So this is going to involve three different properties. Um, so we're going to start with what we would always do first, and that is when we see when we see an exponent. I'm going to zoom in a little bit more. When we see an exponent on the outside, then we know we have to get him into the inside, and he's going to go to that number, and then he's going to go to that power. Don't try to solve the whole thing at once. Don't go all mad scientist mode. And that's not where my mind should be. My mind should be in applying one property at a time. So I'm going to take the -3 and I'm going to apply a power of -4. Good?
But would it be possible?
The last thing in the world that I want you to do right now is figure out what this equals. You should be completely uninterested in the answer to -3. I could tell you what the answer is. It's 1/81, but like that's not where I want you to be. And that's how I would respond if I were you, is be like, what are you talking about? How in the world does that become 1/81? I will show you in a moment. But right now, we're not at a point where we should be worrying about the answer to that. We should be applying the property of distribution, writing it down, and going on to the next distribution. And the next distribution is the green one, and it says, I am already an a to the -3rd power, and you are going to apply to me a new power of -4. Got it? Just talk a lot. If you don't know, the most criminal thing you can do, aside from all the egregious behaviors that we see every day in the school, the most criminally nasty, disgusting thing you can do is sit and not ask a question if you have. What I'm going to do at this point is I'm going to use a property and I'm going to circle it in red. And so much of being good at exponents is just knowing when to do what. If you see a low piece of fruit, grab it. And I see that that green problem is calling to me. What are we going to do, Kobe, with those exponents?
No.
We're going to multiply them. And that's an answer that maybe you wouldn't have given me an hour ago, but now you get it. You know that when something has an exponent and I give it another exponent on top of that, I'm going to multiply those together. So that green thing is going to change. Right, Aubrey? It's going to change. And now what it's going to be is not a to the -3rd raised to the -4th. It's going to be a to the power of 12. It had already a power of -3. I applied a power of -4. I multiply these two exponents together. All day long, what is -3 times -4? Positive 12. So now I'm sitting there and I'm looking at that purple and green problem, and I need to know what to do. Thoughts? Okay, this is one of the hardest things to explain. And this is, I think, where our troubles start is I don't want you to do this math problem. I cannot stress this enough. How weird for a math teacher to tell you, don't do it. Don't do the math problem. I'm telling you, don't. Stay away from it as far as figuring out what it equals. But there's something that we know about it. What about the thing in the red egg would cause me to take note, to pause? It has a negative exponent. I don't give any hoots about the fact that the three is negative. The negative three could be a little drawing of a doggy, it could be anything. I don't care. What I care about is that it possesses an exponent that is negative. And what have we learned that we do with things when their exponents are negative? We either move them to the basement, or if they're already in the basement, then we move them back upstairs. And you all should agree that right now, this thing is just one big fraction. Everything you've ever seen is a fraction. And you could justify that by putting anything over one. Is five a fraction? Yep, it's five over one. So we would agree right now that those two items, the purple and the green, are residing upstairs. So what I'm going to do is I'm going to pick up, and I think this is where some of the stress for you guys starts. I'm going to pick up the negative three, and I'm going to move him down below. He is not going to change. He still says, please call me negative three. I'm not changing. What changes when I move him? The exponent changes. And by changing an exponent to positive, now I'm going to back the heck off and I'm going to stop telling you not to do the math. You should not be mathing something when it's a number with a negative exponent. If I give you 2 to the negative fifth and you say something like negative 10, I'm sending you to the principal's office. Like, don't try to evaluate numbers. That was a joke, by the way. Don't try to evaluate numbers when they have negative exponents. Put them where they need to be and then math them. I could say that 50 times and it probably wouldn't be enough. Negative exponents, do not mess. Move them, then math them. Now that we've gotten to the bottom, and some of you would know this off the top of your head, a lot of you would probably use a calculator to assist you. I can now do the purple problem because his exponent is now positive. What does it mean to raise something up to the power of 4? It means you multiply it by itself 4 times. Here's what it looks like. Negative 3 times negative 3 times negative 3 times negative 3. And I'm about to ask you what this equals. For those of you using calculators, I need to forewarn you, don't you dare say negative. Because if you type in negative 3 to the fourth, your calculator might not know what you mean. What happens when you multiply two negatives together like those? What about these two negatives? So if this becomes a positive and this becomes a positive, then overall my answer better be positive, right? What is 3 times 3 times 3 times 3? So your answer, everybody, should be a to the 12th over 81. Want to go again? That's not an easy problem. I saw that one when I think I made this last night sometime, and I saw that and went, that's a pretty early punch in the gut. That's a tough one. Keep trying, and when you want one, just ask. We still got a couple minutes. Let's milk our time for all it's worth. I'll watch the clock for you, and let's see if we can get one more problem done. Number 4, sure. Um, the first thing I would do in number 4 is I would probably deal with those numbers right there, right? Because they have nothing to do with algebra. So you and I both know that a positive divided by a negative is a negative, right? And you and I both also know that 2 and 2 can reduce to 1 and 1. The way I see it is I think that the twos can basically just go bye-bye as long as I remember to put the negative where they used to be. You good? Now, at this point, what do we do with the ends? I know you want to get out of here. Let's give me a few more seconds. Yeah, Gunnar. Why would you do something like that? Yes, because my teacher, and please don't be packing up. I cannot continue to expect 12 other kids to listen if you're putting things in your backpack. We know to take things that have negative exponents and move them. So we already have an end of the fourth downstairs. We're about to join him with an end to the third. What's left upstairs? Nothing but a one. And what will I do with those ends on the bottom? I will add the powers together, giving me this. Enjoy your Halloween. Be safe. Remember to get lots of chocolate and gummies for your math teacher. There is no Friday school tomorrow. If you need me, come see me later today. Flex lunch. I'd be happy to work more with you. Yeah, I can.